And this 13th group elements, group 3A or 13th group elements in the long form the periodic table consists of boron, aluminium, gallium, indium and thallium. But still we have an element belonging to this group with atomic number 113 known as aniltrium, represented by UUT. So we have boron with atomic number 5, aluminium with atomic number 13, gallium 31, then we have 49, 81, 113. Thus altogether there are 6 elements in this boron family. And in all these elements, the differentiating electron enters into the p subshell of the outermost energy level, having a general valence electronic configuration of ns2 np1. Thus, the members of this group possess 3 electrons in the valence shell. Now let us see the 13th group elements. And thus we have boron, aluminium, gallium, indium, thallium and UUT. Aniltrium. Boron with atomic number 5, aluminium 13, gallium 31, indium 49, thallium 81 and 113 is for untrium, TRIUM. Now once again here, for the purpose of electronic configuration, the element is represented in the column 1, atomic numbers in column 2 and their respective electronic configuration with inert gas core is written. So boron with atomic number 5 is having the configuration of helium 2s2 2p1, aluminium 13 with neon 3s2 3p1, gallium with atomic number 31 having the configuration of argon 3d10 4s2 4p1. Similarly, for this particular element which is not known much, untrium, is with atomic number 113, will have radon 5f14 6d10 7s2 7p1. And if you observe the configuration, we do find the outermost or bit configuration is 2s2 2p1, 3s2 3p1, 4s2 4p1, 5s2 5p1 and so on to 6s2 6p1 and 7s2 7p1. Thus, we are writing the general valence electronic configuration for the members of this group as ns2 np1. And because of this similar valence shell electronic configuration, the members belonging to this group resemble one another in most of their properties. This is the reason. But if you observe the number of electrons present in the penultimate shell, for boron, we'll have the number of electrons present in the penultimate shell as 1s2. In other words, there are 2 electrons in the penultimate shell. Whereas when you go to the neon, it is the 2s2 2p6. Altogether there are 8 electrons in the penultimate shell. And in all the other cases, there will be n-1 penultimate shell, s2, p6 and d10 configuration. In other words, all having 18 electrons in the penultimate shell. So thus there is a difference in the number of electrons present in the penultimate shell of boron and aluminium. Hence boron and aluminium do differ in certain properties due to the difference in number of electrons present in the penultimate shell. And further, boron and aluminium putting together will differ from the properties of the remaining members of the group, as there is a difference in the number of electrons present in the penultimate shell. So the difference in properties is due to different number of electrons present in the penultimate shell, while similarity in properties is due to similar valence shell electronic configuration of ns2 np1.